All right, what's going on, everybody? Welcome back. This is your boy Hank Hackerson at Hank Hacks Hackers, and today we're continuing with our CompTIA PenTest Plus training inside TryHackMe. If you do not have access to TryHackMe, you can get it through the link in the description, and you'll get a discount on an already super affordable membership, and then you can just kind of continue with this. We're on the pathway of PenTest Plus, so make sure that you follow along with us. You can like, subscribe, share, and if you turn on the notification bell, the next time that I drop one of the videos in this path, you'll definitely get notified when the video drops. So the room today is going to be the WireShark room. Yesterday we did, or in the last video in this series, we were in tools and code, and we did the Metasploit introduction in the last video. And then today we're going to do WireShark, then we're going to do Burp Suite, so on and so forth. We're just going to go down this pathway, and then we're going to go to the rest of these rooms as well. And this is all going to be under the PenTest Plus room. So WireShark. WireShark is one of the, I think it's actually a standard, kind of the most used packet capture tool that exists out there. And it's also the tool, I mean, they've used it in Mr. Robot, so you can actually see them using this in Robot. It's a packet capture, meaning that it can capture traffic from whatever network you're on, and then you can analyze that traffic. And if certain transactions are done in that traffic, meaning like, let's say you're in a coffee spot, like a Starbucks or something, and you connect to their Wi-Fi and you start capturing their traffic. If other people are connected to the Wi-Fi and you start capturing that traffic, you could potentially see the traffic that every other person is viewing on their phone or on their computer. And if somebody logs into their bank account, for example, and you can capture that traffic. And I'm not telling you to do this, by the way, because that's super illegal. And if you get caught, you get, it's a felony and you're screwed and shit like that. But that's potentially it. And then you capture the traffic, and then you can see the packets of that transaction, and in there might be the cookies that have been saved that show the person's username and password. Obviously it's not going to show it in plain text, but you would see the hash value of those things, and then you can decrypt those things and decode them, so on and so forth. So not saying to do it, but this is a very useful tool, and it's open source, meaning it's free. And this room, by the way, actually, so as we can see it down here, the WireShark room is also a free room, meaning that you can actually join without having a full subscription, a paid subscription, and then you can launch this room and go ahead and start the machine right here, and then the machine will allow you to run WireShark. So it's pretty cool, and there's the machine loading on the side right here. So we're going to read into this real quick. I'm gonna minimize this so it doesn't mess with me in the middle of the reading. And then once that loads, we'll actually start running some exercises inside of WireShark so you can see how it works, right? So here we go. The introduction to WireShark is an open source cross-platform network packet analyzer capable of sniffing and investigating live traffic and inspecting packet capture. So they're called PCAP files. It's commonly used as one of the best packet analysis tools, and we're going to look at the basics of WireShark. The virtual machine is attached to it. You don't need SSH or remote desktop protocol to do this. So once it's launched, you could just do the split view that's at the top of the screen, so on and so forth. So which file is used to simulate with the screenshots? And I mean, I already have an answer to this, but I think it's because it's inside the room already. So it actually tells us, right? There are two capture files given in the VM. You can use HTTP1 PCAP to simulate the actions shown in the screenshots. I mean, it's already here, so it tells us this is what's used to simulate the screenshots. And then please note that you need to use the exercise PCAP file to answer the question. So that's what was used to simulate screenshots, and then that PCAP file is what's used for the exercises with the rest of the room. So let's see if this has actually been loaded, so we can kind of see almost. So the tool overview, let's look at this a little bit. So it says WireShark is one of the most potent traffic analyzer tools available in the wild. There are multiple purposes for this, so you can detect and troubleshoot network problems such as load failure points and congestion. You can detect security anomalies such as rogue hosts, abnormal port usage, and suspicious traffic. And of course, you can investigate and learn protocol details such as response codes and payload data. So it's used for a lot of different use cases. And obviously, since we're in the pen test room, that means that you can probably do pen testing with this thing as well. So you could capture data and you can use whatever information you've captured to use to pen test. And so this thing that we've opened on the side right here, this is the HTML PCAP file that is used to go through. I mean, at first glance, if you don't know what any of this means and if you've never seen anything like this, it can be overwhelming because it's basically just lines of data. But just to kind of, and I might be getting ahead of myself, I'm sure we're going to cover this in a little bit as well. But so this is the time of so the number of the packet, the time that it came through, the source IP address, the destination IP address, the protocol, so TCP or HTTP or DNS, right? The length of it, so how many bits, and then the information in the actual file itself. So it's kind of like a snapshot of what's inside the packet. And so it went from port 3372 to port 80, and then this was a response. So it's a SYN. SYN is the first packet that goes on in a TCP handshake. And then you have the second packet, which is SYN acknowledge in the TCP handshake. And then the third packet, which is acknowledge, meaning that it's actually been a completed TCP handshake. And so you can see that it went from 3372 to 80, then 80 responded and acknowledged it, and then 3372 acknowledged that last one, and now they have a full TCP handshake. That's just a sampling of what that could look like, right? So this IP address sent the request to this IP address, that IP address responded back, and then this one finalized that response. And that's very simple TCP handshake. And this is basically just to kind of give you an overview of what this particular file looks like. And then if I go back to the desktop real quick, we're going to be using this file to answer the questions. And so we're going to let that load. And so here we go. So the WireShark GUI, graphic user interface, with a single all-in-one page will help investigate the traffic in multiple ways. At first glance, it gives you several sections that stand out. There's the toolbar, the display filter bar, recent files, capture filter and interfaces, and the status bar. And so we can kind of look at this right here. So this is the toolbar, the display filter bar, where you can filter out all of these results that came out. On the home page, this is kind of what it looks like, where it says these are the recent files that you used. If you want to capture traffic on a network on the home page, let me actually show you also what this looks like so that you can actually see what's up. So let's just go to, can we close this out? There we go. So this is, right, so this is exactly what they're talking about. This is the toolbar up here. This is the filter bar right here. We have the recently opened files, which were the last two files that I opened. If I wanted to do a capture, I could just do a drop down and it would show me what all network interfaces are available, but this particular virtual machine doesn't have anything connected to anything, so there's nothing here. But whatever network you're connected to, so whatever Wi-Fi network you're connected to or Ethernet network you're connected to, it'll show you all of the machines that are here, and you could just do all interfaces shown, or you could choose one where you want to capture the traffic for that specific IP address or machine. And then whenever you're ready, you just go up here and then you press start capturing, and it'll start capturing packets on whatever machine you've designated. So right here, this is kind of what it looks like, right? So if you click on this section, these are the potential interfaces that you can capture traffic from. And then this line right here, it shows you how busy that interface is. So these three interfaces at the top right here there has been no traffic because there's no squiggliness in their line, right? And then so ready to load capture, no packets, this is just the status bar. So if you want to load a PCAP file, we could either just do open right here, where we just go and we do open and we find a file, or if it's a PCAP file, you double click it the way that we did before and it will open it for you. And then it just shows us what's inside the thing, right? So we did that already. and we went through the packet list already, and then there, for each whatever one you click on, it'll give you the details for that packet. And then there's another view where it just shows you the byte view, which is, I mean, I still have a tough time analyzing these things. The only thing that I know how to analyze are the first 2 bytes right here, which I know determine what kind of protocol or packet it was. And I haven't memorized it, but I know that it's important if you can understand. If you figure out what the first 2 are, and then you go and you Google what type of packet is this, and then you give it those 2 byte data, it'll say, oh, it's this kind of a packet. But that's basically what I know about looking at these types of information right here. So there's the packet list pane, which we saw, packets details, and then packet bytes by pane. And then coloring packets. This one is kind of important. And so you can establish coloring rules, as it says right here. And, you know, the red ones are of importance. Like, you should know, hey, this seems like shady because WireShark is flagging this already as something that we need to look at. There is the black. So let's see if it actually tells us what the colors are right here. It does not tell us what the different colors are. I think black is even more crucial or severe to consider. But if we wanted to just see, we could just click on coloring rules. So it just tells us right here. So it says you can use the right-click menu or view coloring rules to create permanent coloring rules. The colorized packet list menu activates, deactivates the coloring rules. Temporary packet coloring is done with the right-click menu or view conversation filter menu, which is covered in task 5. So we'll go through that in a little bit. And this is the default permanent coloring is below, right? So green should be fine, looks normal. Yellow is of a little bit of importance. Red, black, those things you definitely need to pay attention to. So you can use the blue shark button, which we already discussed, to start network sniffing or capturing traffic. The red button will stop the traffic, and the red button is just a big stop button, which, you know, for every platform or every device known to man, if you press the square, that typically means stop. And then in this particular case, there is no green play button. It's just a shark button that starts capturing the traffic. And so it'll start capturing traffic, and then you can merge PCAP files that will look like this. So file and then merge. And the reason for that is to try to see if there's overflow or overlapping in any kind of a packet that's been captured, or multiple packets, capture files that have been gone through. And then so when you do that, you get to see where the overlaps are. And maybe you're doing it through multiple devices or multiple IP addresses. So it's important to know those things. And then knowing the file details is helpful, especially when working with multiple PCAP files. Sometimes you will need to know and recall the file details, which is the hash value, the capture time, the comments inside the capture, interface, statistics, all of these things to identify the file and prioritize it. You can view the details by following statistics, capture file properties, or by clicking the PCAP icon located on the bottom left of the screen, which is this little thing right here, that little thing. And it'll show you the statistics and the properties of the specific file. And it basically opens up what would be shown down here in a much larger window, and then you can kind of see all of the details of it and further analyze what that packet is. So, okay. So read the capture file comments, and I'm gonna show you what it actually is. So we're gonna kind of go through the thing. So it says use the exercise PCAP file to answer the questions. Read the capture file comments. What is the flag? Okay. So let's open it back up. And what we need to do is we need to go to statistics and properties. And it'll show this thing, it'll open this up for us. And then if we just go down to the comments at the bottom right here, capture file comments, it should show us something about this file. Let me see if I can kind of make that a little bit wider, can I? Should be able to, there we go. So flag right here. So it's inside the comment section, and all we had to do was we just had to go to, one more time, statistics, properties, and it'll open up everything about this entire capture file, and inside that we could see if there are any comments attached to it. And then what is the total number of packets? This one is kind of easy. You just pull this all the way down, and you just look at the number of packets, and 58,620, that's the total number. 58,000 packets were captured. And this is, by the way, if you're on a busy network, it literally will be tens of thousands, if not hundreds of thousands of packets that'll be captured, which is why it's really important to learn how to use this display filter at the top, because you're not going to scroll through every single one of these things to try to figure out what's going on. You know what I mean? So you kind of want to learn how to use these display filters, and it'll help you out a lot. So what is the SHA-256 hash value of the capture file? And so we probably will find that here as well, capture file properties. And then we have the hash SHA-1 and then SHA-256. So it's at the very, very top. And so that's it, right? So SHA-256 hash value is this thing right here. So you do that, copy, and then you go inside the flag and you paste that, and that's how you find the hash value of the file. So easy enough. Moving on. Okay, packet dissection is also known as protocol dissection, which investigates the details by decoding available protocols and fields. It supports, WireShark supports a long list of protocols for dissection, and you can also write your own script to dissect furthermore. And then there's details on it here, which is at the WireShark GitHub page, and it'll show you way more details on dissecting packages. And I'm not gonna go through this whole thing, but if you want to, you're more than welcome to. And WireShark, again, is one of those tools that if you get really good at WireShark, you will most likely stand out among all of the other applicants if you're trying to go for a cybersecurity analyst job or a pen tester, offensive security, red team type of a job. So this section covers how WireShark uses the OSI layers to break down packets and how to use these layers for analysis. It's expected that you already have background knowledge of the OSI model. If you don't, just Google that. Very easy. And we'll just do that real quick. Search Google for the OSI model. And right here, very, very simple. It's a conceptual model created by the International Organization for Standardization, which enables diverse communication systems, whatever. This is it. So this is what you really need to know. That entire definition means nothing. So the OSI model starts from the physical layer, which is the actual machine, and then the data link layer, which is the format of the data on the network. So basically how the machine connects to the network. So these are wires or routers and stuff like that. And then you have the network, and then you have the transport layer, whether it's TCP, UDP, it could be HTTP, the session layer, so connections and what is responsible for controlling ports and the sessions that are used. Presentation layer, which is basically what type of application, not the actual application itself, but what is being done to present the information onto the screen. And that layer itself is important. And then the application is the actual application that you're using. So is it Google Chrome? Is it the network? Technically, WireShark itself falls under the application layer. So that's kind of a very brief overview of the OSI model, but you should definitely get to familiarize yourself better with that. All right, so packet details, here we go. So if we click on a packet, it'll give us the information right here in the packet capture video, section, excuse me. And if you click on the frame, it'll give you these details, and then you can click on that little arrow and it'll open that up for you. And then you can click on any of these other things and it'll open that up for you. And so each time you click a detail, it'll highlight the corresponding part in the packets pane, which is on the right side of the screen. So let's have a closer look at this thing, right? So first and foremost, frame 1, which would be layer 1 of the OSI model, that bottom layer that we saw. This will show you what frame packet you're looking at and the details specified to the physical layer of the OSI model, which is the very, very top thing. So this at the top is for layer 1 of the OSI model. So it'll show you physical or data about the physical information, right? So it'll be through the Ethernet. Let's see what else is very important. Ether type, right? IP, TCP, HTTP, etc. Layer 2 will be the MAC address, or the layer 2 of the OSI model. So it'll show you what it is. Destination came from Xerox, source went to this particular MAC address. type IPv4. So layer 3 would be source IP address, so internet protocol version. It'll give you information about the source IP address, which is right here, and the destination IP address, which is right there. And there's a lot of other information in here, the flags that were attached to this, and we can just kind of go through that a little bit later. Layer 4 would be the protocol that was used. So it's on the transport layer of the OSI model, so it tells us right here. So this is the network layer, which is layer 3. This is the data link layer, which was layer 2, and layer 4 is the transport layer, which is layer 4 of the OSI model. Transmission control protocol. So it went from port 80 to port 3371, and the source port, information about the source port, any flags that were attached to it, and then timestamps and the sequence, acknowledgement, etc., etc., etc. Protocol errors. This is a continuation of fourth layer showing specific segments from the TCP that needs to be reassembled. And so this is the reassembling of the TCP segments, and it shows you what other packets or what other frames are relevant to the individual packet that you're looking at right now. And application protocol, which would be layer 5. And so this is it. So this is hypertext transfer, so HTTP. And it gives you information about that, right? So where was it? It was going to this IP address, it seems like, and content encoding, content length. The request for this particular one is in frame 18, and this is the HTTP, the URL that it interacted with and it went to. The application data layer looks like this, and whatever application it was using. And now that we understand what a general packet is composed of, let's try to answer these questions. So view packet number 38. So I'm just going to go all the way to the top. Was not trying to do that. Going to go all the way to the top. And I think there's also even the option that if we click on here, if I do Control F, it'll let me do a little find. And if I do 38 find, it'll just bring up packet 38 for me. Or it actually looks up 38 in all of these things, so maybe not. Okay, so here's packet 38. Which markup language is used under the HTTP protocol section? So if I go here, we're just gonna kind of drop that down. So HTTP protocol section right here, and then it says markup language. So let me see if I can, maybe if I do a full screen of this, there we go. Makes it a little bit easier. And the markup language, let's try to scroll through this. It actually is not under that. I should have known this very beginning. It's actually under the extensible markup language, as it says right here. So that's basically it. That's the language that we're using. The extensible markup language under HTTP. That's what I guess the hint was, right? So packet numbers are shown on the left. Well, we already know that. So under the HTTP protocol, so this is it. The answer is extensible markup language. That's the actual answer. What is the arrival date of the packet? The answer format is going to be this. So to try to find that information, we just need to go look at the details of where it's going to be at. So arrival time, it's at the very, very top under the layer 1, frame 38, that information. As long as you just drop that down, it'll show you right here, arrival time, May 13, 2004. And that's the actual time, universal time. I think that's what UTC stands for. So 5/13/2004, and that was the answer. What is the TTL value? TTL value stands for time to live, and in the hint it says that it would be under the IP protocol section. So IP is Internet Protocol version 4, so that's the section that we're going to look at. And TTL right here is time to live. And so the TTL value is 47, as we can see right here. And what is the TCP payload size? So if we go to the transmission control protocol and we're looking for the payload size, and at the bottom of the transmission control protocol it says TCP payload 424 bytes. So 424 ends up being the answer. And what is the E tag value? And the ETag value is under the HTTP, the Hypertext Transfer Protocol section, and it has its own line item called ETag. And so you just copy that and then paste it. Although I think what I did was I opened it maybe to be able to copy paste it, because I don't think you can copy this. Oh, no, if you right click it, it'll give you copy, and then you can copy the value of it, and it'll give you the value of that line, and then you can go ahead and paste it into your answer. So there you go. We just analyzed our first line item, our first packet from our PCAP file. So let's go to the next one, packet navigation. All right, so packet navigation, this is when you're trying to search for things and try to figure out what you're looking at. Basically, we kind of first dove deep on one packet. Now we want to kind of try to see how we can find the packets or relevant stuff, moving on. So, okay, so WireShark calculates the number of investigated packets, assigns a unique number for each packet. So to go to the packet, you can just do Control G, or you could just go and then go to packet, and it'll bring it up here. And then you can do go to packet, and it'll bring up the packet for you. And so I think I did Control F for find, and when I did that, what it did was it found whatever information in this entire series of packets that have the numbers 38 in it. So if I went to go to packet and then actually typed in 38, or well, now it's giving me 3. So if I did 38, go to packet, it went to packet number 3, go to packet 38, do that, there you go. Now it's going to go to packet 38. So we could have done it that way, and then it will bring it up for you onto the screen. And if you want to find packets, so this is the apart from the packet number, you can find packets by the content of the packet. So you could do edit, find packet, and then make a search inside the packets for a particular event of interest. So for example, you could do display filter, hex, string, regular expressions. The second point is choosing the search field. You can conduct searches in 3 panes: the packet list, the packet details, and by packet bytes. And it's important to know available information in each pane to find the event of interest. For example, if you try to find the information available in the packet details pane and conduct a search in the packet list pane, WireShark isn't even going to know, isn't going to find it even if it exists, because you just used the wrong section to find it. And then you can mark or unmark packets, right? So marking packets is a really helpful way of functionality for an analyst. You can find or point to a specific packet for further investigation by marking it. It helps analysts point to an event of interest or export particular packets from the capture. And then you can click on edit, and then right-click menu, either edit or the right-click menu to mark or unmark packets. And then it kind of shows us a screenshot of that. Then you have packet comments. So if you click on a packet, you could either right-click or go to edit and then just view on packet comments, and it will show you any comments relevant to that specific packet. And then of course you can export packets. So you can click a series of packets or an individual packet and you can export it. Then you can export objects. So there's specific parts of the packet that you can export. For example, the HTTP portion of that packet, right? So WireShark can extract files transferred through the wire. For a security analyst, it's vital to discover shared files and save them for further investigation. Exporting objects, which are either the payloads or the actual files that are attached to something, for the stream that you're looking at, so DICOM, HTTP, IMF, SMB, TFTP, etc. You can export those objects. Then there's the time display format. So everything right now I think is being viewed by UTC, but you can, it says date and time of the year of the thing. You could do seconds since the beginning of capture. There's a lot of different things that you could look at, and I think you could even change the time zones. then it'll change it for you, right? So UTC time display format, it'll actually change the different views for it. So that this one is time, seconds since the beginning of capture, and a UTC time display format. These are the two different ones that it looks like. Expert info, right? So severity, blue, light blue, yellow, and red. So chat, basically it's a regular conversation. Note, notable events like application errors or codes. Warn, meaning unusual error codes or problem statements. And an error is problems like malformed packets. Those are the types of things that you could look at when you're looking at expert info, which is one of the other details shown in WireShark. And then you have checksums and comments. So frequently encountered information are listed in the table below, like checksum errors, packet comment section. It could be deprecated or it could be malformed, and that's basically the information of it. The lower left bottom section, which is that little thing that we found at the bottom right here, that little thing can bring up this information. So the expert information, you can also find it under Analyze Expert Information, and that's where these notes come in from. That's where you can see these different color packets, or the colorations, excuse me, of the individual notes about that particular packet, and it can kind of help you analyze the packet easier if you don't know what's going on, or so on and so forth. So search for R4W string in the packet details. What is the name of artist 1? So we're going to go to, what we're going to do, we're going to search for, and it's not go to packet, it's find different details of the packet. So let's see if we could just search for R4W. So if I do Control F and do R4W and find, okay, it brought that information for us, and this seems to be the line that it's on, and it says artist 1. So let's kind of zoom in here. So it found the piece of the string that actually is attached to, and it's under the truncated, and this is under what exactly? This is under the line-based text data, the text HTML, which is under the HTTP portion of this. And so it goes directly to the line that that specific thing exists in. And then so this is it. So that's what it found for us, and it says artist.php artist1 equals that. And so that's the answer that you want, and that is indeed the answer of the question right here. Then go to packet number 12 and read the comments. What is the answer to the comments of packet number 12? So if we just do go to packet 12, enter, it'll bring up packet 12. If I click on that, and I believe it is packet comment, and so this is what's in here. This is not a flag, this is not a flag. Anything else here? Go to packet number 39765 if you want the rest of that information, it seems. So what is the MD5 hash value of the extracted image? So 39765 is going to be what we're going to continue to search for, 39765. And it's a JPEG file image, and that's what the previous comment asked us to look for. It says, what's the hash value of the JPEG? Okay, so we were able to find the packet itself. We know that it's a JPEG that's attached to it. If we go to statistics and we do capture file properties on this packet, come down to the comments section, and at the end it says packet comments. Go to the packet number, look at the packet details pane, right click on the JPEG section and export the packet bytes. This is an alternative way to extract data from the file. So what is the MD5 hash value of the extracted image? So if we do this, right click on this, click on that, export packet bytes, and I guess save it here. So we'll just do bytes on the desktop, save that. Let's see what we get. Go here. Okay, so we had to first download the thing, and this is kind of, I'm glad I remembered this. I almost forgot how I got this thing, and I didn't have to Google it this time, which I'm very happy about. So we downloaded the file by going to the actual line item. We found the second packet, so because it told us to go to packet 12 and read the comments. We read the comments, and it brought us to 39765 as the packet. Inside that packet, we can see that there's a JPEG file attachment, and so when you right-click that and you do export bytes, it allows you to export the image itself. And so we exported the image, and this is the image right here, and it's on my desktop. And so I basically went to CD desktop. I changed my directory to desktop. I found that the file is right here. And to find the MD5 hash of anything, you just do MD5 sum and then the name of the file or the path to the file, and it gives it to you. And that's the MD5 sum of this particular packet's contents, so on and so forth. So we found that, which is great. So now there's a TXT file inside the capture file. Find the file and read it. What is the alien's name? And obviously it says it right there, but let's go find this TXT file. Okay, so what I was actually supposed to do, and it's been a long time, so this is a nice refresher for me. So we're supposed to go to, I believe it is File, Export, Objects, there you go, HTTP. And then in here, we're supposed to filter for TXT. And it'll bring one particular packet that has a TXT in it. And then we're gonna save it. There's a file name attached to it, which is note.txt. We're gonna save that on our desktop with the rest of the stuff that we just saved. And, oops, I already clicked save. We're gonna close that. Then we're gonna minimize this and should now have a note.txt. So if I do cat note.txt, and this is what it is right here. So that's the actual contents of this thing. And if you kind of open it up, it might be a little bit easier to view in the terminal. Yeah, it's actually easier to view in the terminal. For some reason, the text editor wasn't really that good. So packet master, you can kind of make out what that says. And that's the way that you find it. So essentially, what's important is for you to learn how to find the TXT file inside this thing. And so if you go through File, Export Objects, HTTP, and then you type the .txt in here, that's where you would find the file that is relevant to this. And then so that's it. So now, last piece that we got to do is expert info section. What is the number of warnings? And so this is how we found expert info, is to go through, what is it, app data, I think, or analyze, and then expert information. So analyze, expert information, and the number of warnings. So this would be a warning. Oh, there you go. It's actually at the very end of it. So the count is right there. So 1636. That's the number of warnings. So you didn't even need to go through the entire list. If you just go to the end, it shows you the count and the number that is associated with whatever is under this section. So the number of warnings under expert information is 1636, and we got that as well. So moving on to packet filtering. So there's a powerful filter engine that helps analysts narrow down the traffic and focus on the event of interest. This is actually very, very useful. Filters are specific queries. So instead of reading all that, let me just show you what that means. So it's right here. So if we go to the apply display filter, you can start searching, either type it in yourself, or you could actually even click on one of the packets and apply that packet as a filter, right? So if I went here, click on a random one, do this, and then apply as filter, selected, and now it shows you. So frame time, relative such and such. Oh, it's the section that you also apply as filter. So that's another thing. So I clicked on the frame time. So if I click on this, for example, and use that and apply the IP address as filter, then it'll apply that IP address as the filter, right? So it'll show everything that has to do with that source IP address. We can X this out. We can go to, let's say, the What else could we use that might be relevant or relative, useful? Maybe we could do, let's see. Well, it'll probably give us some things to filter for. So when you use the applies filter option, you'll filter only a single entity of the packet, right? The option is a good way of investigating a particular value in packets. However, suppose you want to investigate a specific packet number and all of the linked packets by focusing on IP addresses and port numbers. In that case, the conversation filter is what's useful. So let's go back here and let's click on this thing, do this, and then go to conversation filter. And then we can do, pretty much everything that has to do with that. So let's say TCP. We want to use the TCP as a conversation filter. And so these are the list of everything that has to do with that packet in the conversation filter type, right? So TCP, these are all the TCP packet types. And it says right here, so the IP address equals that, and IP address equals that. So two different IP addresses, and the TCP port equals this, and TCP port equals 80. So anything that has to do with any of these things will show up inside your filters. This option, so the colorized conversation option, is similar to the conversation filter with one difference. It highlights the linked packets without applying a display filter and decreasing the number of viewed packets. This option works with the coloring rules and changes the packet colors without considering previously applied color rule. And then you can use the right click, view colorized conversation, to colorize a linked packet and a single click. And then you can do view colorized conversation, reset colorization to undo what you just did, right? So we could do right click on the packet, colorize the conversation that has to do with TCP, and then choose a color that you want. And every single conversation that has to do with that will show up. And it won't remove any of the other pieces, unlike the other one which actually removed all of the other packets. But what it'll do is it'll colorize everything that has to do with that conversation according to your conversation filter. And then if you wanted to, you could just go back and reset that. So prepare as filter. Similar to apply as filter, this option helps analysts create a display filter from the right-click menu. However, unlike the previous option, this doesn't apply the filters after the choice. It adds the required query to the pane and waits for the execution, which is enter, and another chosen filtering option, including and or. So it'll fill this up here for you. It just won't actually do it. It'll fill that up, and then if you want to do and another filter afterwards, or another filter afterwards, you could do that. So it'll prepare this thing or that section. So instead of applying it, so let's do this. We'll do prepare as filter, the particular thing selected, but it won't actually filter it. It waits for me to press enter, and then once I press enter, it'll actually apply the filter. And if I wanted to, I could do or, and then bring another thing. So IP destination, is that DST? There you go, DST host equals, let's say we want to do, are they all the same destination? It seems to be that they're all the same destination. But whatever, let's say I want to do and actually. So I want to do the source address is that, and the host destination is 10.10.57.178. Let's say that's the filter that I actually want to apply, and it'll double up and it'll show me everything else. So it prepares it as a filter, and then you can add to it later and then press enter. Then you got the filtration for apply as column. So you can click on a packet, right click menu or analyze apply as column, and then it adds columns to the packet list pane, right? Once you click the value and apply it as a column, it'll be visible on the packet list pane. This helps analysts examine the appearance of a specific value across the available packets in the capture file. So right click on this specific portion right here, apply it as a column, and now it'll bring everything in the type on the actual packet list under that specific type. And then you could do that, apply as column. And then the follow stream, which is very useful as well. So It's possible to reconstruct the streams and view the raw traffic as it's presented in the application level. You can right click or analyze follow TCP, UDP, HTTP stream to follow traffic streams. They're shown in a separate dialog box like so. And packets originating from the server are highlighted with blue, and those originating from the client are highlighted with red. So it shows you the TCP conversation stream right here. And it'll also actually say that there's 43 packets that are in that stream, and then it'll display all of that inside this new window for you. Then you got that. And so let's say go to packet number 4, right click on Hypertext Transfer Protocol and apply it as a filter. Now look at the filter pane. What is the filter query? And we already have an answer, but let's do it. So let's just go to packet number 4. Packet number 4 isn't displayed, so let me exit this out. And let's go to packet number 4, enter. And there you go, that's packet number 4. And it says right click on Hypertext right here. And then apply it as a filter. So we're going to apply this as a filter. And now it should show you everything that's under the protocol, which is HTTP, which is the correct answer. So what is the number of displayed packets? And if we look at down here, it'll show us displayed 1089. Okay. Go to packet number 33790 and follow the stream. What is the total number of artists? Okay, the problem was I was searching the TCP conversation when I was supposed to be searching the HTTP conversation. So let's see if this one actually does a better thing for us. So if we do artist.php, and then the artists themselves should be showing up, I think, because all of this was just like BS before, and we couldn't even find the information. So category is artist.php, artists, and then there's disclaimer, Okay, so we got the first one, it seems, is this person. Let's see if we can find artist number 2. Artist number 2 is right here. And let's see if we can find artist number 3, and they are right here. So we got 3 artists. And what is the name of the second artist, which is Blade or Blad number 3. Okay, so there you go. This was a little bit trickier, but the simple response was go to the packet itself. Since the packet, and this is kind of the hint, right? So if we go to the protocol of the packet, it's HTTP, and when you right click it and you want to look at the conversation, it gives you 2 options. So you can do follow TCP stream, which was what I initially chose, but you're supposed to actually do HTTP stream, because if you do TCP stream, then everything else, it looks, look at this. This is just BS, right? You can't, I don't know what any of this would be broken down to. So you're not even looking at, or I wasn't looking at it correctly. So when you go back to here and then do the same thing, but now do HTTP stream, it'll actually show you the contents of all of those things. And look, this is all legible, and you can analyze this, and you can even search for the contents of it. So that's the key factor right there. And that was it. And so this is it. We are now at the conclusion that we just finished the WireShark Basics room. And then we can go to another one, which is packet operations, which is a follow-up room. And I wonder, oh, I haven't even done this. So this could be a nice follow-up to packet operations for WireShark. So that would be pretty cool to do. And I will definitely do that because I have not done this room. So that would be fun to do. So anyways, so here it is, right? This is the WireShark introduction, the basics of WireShark. I'm going to terminate this thing. And I hope you learned some good things. If you've never used WireShark before, it's definitely very useful, especially when you get really good at the filtering and following conversations and knowing what you're actually looking at. And as you just saw, I haven't done the follow-up to this room. So it'll be even useful for me to do that, and I will do that. And you best believe there's going to be a recording that comes with that. And we can just learn more and more and more about this, because this is very useful for defensive security as well as offensive security. So WireShark Basics, this is your boy Hank Hackerson at Hank Hacks Hackers. I hope you found this room useful. I hope you learned, and I definitely got some nice review content, so that was very good for me as well. So this is nice. It's nice to be able to review some of these things with you here with me, and hopefully you'll be learning with these things as I review them for myself as well. So there's that. Make sure you like, subscribe, share, follow, comment, turn on the notification bell so that you get notified the next time that we drop something. And if you don't have access to TryHackMe, definitely get yourself a membership, because this was one of the free rooms, as it says right here. So I'm pretty sure that just from the free rooms, you'll get a lot of value. But if you use the link in the bio, then you'll go ahead and get a discount on the paid subscription as well. And there's a lot of cool stuff. When you get to the intermediate and advanced stuff, all of those are paid. So definitely go ahead and get yourself a membership either way and try all of these out. And let me know if you have any questions, or let me know how you progress with each room. And yeah, I will see you in the next video. Peace.